Hey everybody, Paul Chin Jr. here, back with a brand new fresh episode of Talking Serverless, sponsored by Serverless Guru. On Talking Serverless, it's a podcast about serverless, and we talk about it. It's a pretty straightforward concept. I think all of our listeners sort of appreciate the simplicity of the podcast. And today I'm really excited. I'm calling it an event to remember because we're bringing on James Eastham. He does a lot of really great stuff in the community. I've watched his developer talks on YouTube a bunch already, and he's a pretty common mainstay member of the Believe in Serverless Discord. And I think with that, I'm gonna just turn it over to James. James, welcome to the show.
Hey, Paul. Thanks for having me on. It's super exciting. It's long time listener, first time caller type situation. I've been listening to the podcast for a while, so it's super exciting to be here chatting.
Nice. Yeah, I'm just as starstruck as you are. So I think this is equal levels of fanning going on. And with that, James, could you just briefly introduce yourself and kind of tell us what's going on with you currently and what kind of stuff you're getting into?
Yeah, absolutely. I'm James Eastham. I'm currently a developer advocate at Datadog, focused very specifically on serverless technologies. So that kind of what that means in day-to-day life is that I spend my days connecting with the serverless community, engaging with the serverless community, obviously with a observability angle to a lot of the things I do. But first and foremost, my job is about connecting with the serverless community and being in the serverless community and demonstrating serverless things, which is kind of cool. I've been at Datadog for about 6 months now. Before that, I was at AWS for 3 years, just over 3 years. Interestingly, doing a lot of professional services consulting type work inside AWS. I always used to say, by day, I'm a consultant. By night, I'm a serverless developer advocate who talks a lot about serverless things. So I've been doing this for quite a while now, but this is my first time actually doing it as a job. If we go a little bit further back, I suppose my history is in development, software development. I'm a .NET developer I'll let the audience treat that however they want, whether that's a good thing or a bad thing, I'm not so sure. I've done a lot of .NET development, a lot of apps deployed both to servers, to Windows servers, to serverless things. Pretty varied up until this point.
So you really know what it's like to have the full ops on the back end with a .NET app, right?
Yeah, the story I always like to tell is I was once back when we all worked on desktops rather than all everyone seems to have laptops nowadays. I was at work one day and I was sat at my desk and I'd been remote desktoped into a production server because that's how people used to do things. And I just shut my laptop down. I shut my computer down. So shut down on Windows. Off I went. 10 minutes later, I had a call. Like the production server has just gone offline. Turns out I'd been remote desktoped into the production server and I'd shut down the server instead of shutting down my laptop. After that, all the desktops on all the production servers were bright red so that people knew when they're in production. So yes, I felt that pain very, very, very personally, as I think most people have who've deployed things on servers, right? Most people have got war stories from things like that.
I mean, I always say if I have to remote into anything, I've messed up.
Yeah. Yes, that is absolutely. Yeah.
Yeah. Early on when I was still learning development, I was lucky enough to be born in the cloud, right?
Mm-hmm.
When I started learning, AWS Lambda had just come out, and that's just what I started with.
Yeah.
And since then, I've been backfilling sort of the institutional knowledge of how to keep these machines running and, care for them and feed them. And so I wanted to get your take on this evolution, right? Like you went from these big, I guess, monolith type applications, and then microservices sort of became the buzzword. APIs, everything had to have an API, the API economy. And now we're just screaming about event driven. Everything's event driven. So tell me about that sort of evolution and change as you saw it throughout the industry through your work.
Yeah, absolutely. I think I've been there deploying all types of systems. Like back when I started building things, a lot of the first system I ever worked on was a monolith. The first few systems I ever worked on were more monolithic systems. It was a little while into my career till I truly came across something that was microservices for the right reasons. I guess is how I'll put it. Because I think microservices they're solving an organizational problem, right? Although they are a technical thing, microservices are really useful when you've got lots and lots of people all contributing to the same code base. Like one of the biggest software mistakes I've made in my career was I was a single developer working on a project for a startup, and I built it as microservices, and it just caused me so many more problems because I've got all these moving parts to deal with, and I'm the only person. So that decomposition down to microservices, I think, kind of makes sense when you've got lots of people, lots of teams all contributing to the same code base. They're getting in each other's way. They want to deploy and build things independently. Like, we all know the benefits of microservices. But I think one of the challenges microservices raised, particularly with that point you've just made about like the API economy and everything having a synchronous API, is that although you solve organizational complexity and you solve some element of technical complexity because you've got these smaller, more focused pieces, in my opinion, it dramatically increases the integration complexity. Like, how do you make these things talk to each other? How do you make these things communicate? And if you're doing a lot of synchronous communication, the thing that you're talking to needs to be online at the time, what would be called temporal or runtime coupling. At the moment, one service is running, any other service that service needs to communicate with needs to be online at the same time. And that is hard. Like, now you're not just keeping one, like you said about coding for machines, you're not just coding for one machine on its own. You technically need to keep tens, hundreds of machines online. And I think that's where, I mean, if I say that's where event-driven architecture comes into the picture, but, you know, building things with events in software is not a new shiny thing. Like, it's been around for years. Like, when I first started developing in .NET with Windows forms, you did things when buttons were clicked and mice were hovered and, you know, keys were clicked and things like that. So events aren't a new thing, but I think the current state of play that we're seeing, where more and more people are starting to build event-driven systems, I think it's just a natural extension of that. Hey, we've broken things down to microservices. That's great. Now it's really hard to get things to communicate reliably. Well, let's just try and reduce some of that coupling as well, and get things communicating in a more asynchronous way.
Yeah, I think for people that are looking at event-driven systems, I try to say, like, there's a difference between distributed computing and asynchronous and synchronous computing, right? Like, just because something's distributed doesn't mean it'll automatically take advantage of the decoupling. If everything is still very synchronous, like you mentioned, like it's just waiting for the next call, and it doesn't have any way to parallelize throughout the system, then you're still really just making a monolith, but the monolith is like huge with lots of layers, right? Like I guess the trope of microservices design is like, oh, we have this service and this service and this service, and they're all independent. I was like, well, if you take out one of the services, the rest of them still can't operate, right? So tell me about how you've been helping other people, clients, customers, sort of understand that distinction of where that complexity they need to own.
Mm-hmm. One thing I always like to say at this point is, like, it is entirely possible to build microservices architectures in a reliable way with synchronous communication. Like, I always like to point that out. You know, there's patterns that exist in the industry for like circuit breakers and exponential backoff and retries and all these things that exist. But when it comes to event-driven systems and asynchronous communication, I think another one of the common misconceptions I see, if I can answer your question in a slightly different way, is this idea of like decoupling. And I think this is where some of the challenges when I've seen people adopt event-driven systems start to come in. Because to me, the word decoupled means that something, if I think like a train, and a train, you've got multiple carriages. If you decoupled the train carriages, they're not connected at all. And actually, when you build an event-driven system, you still have coupling. Like, coupling still exists. If you decoupled all of the services inside your system, it'd be really hard to get any work done because nothing's communicating with each other at all. And I think I've seen it often enough for it to be a problem, that people think because, hey, well, these things are decoupled, they can just work independently now, and we can just publish events and we can just subscribe to events, and yay, decoupling, and everything's magic. I think that's where you start to get into issues, because there is still coupling in an event-driven system. Things still are coupled together because they have to be to do work. Like, we break things down into microservices, but we're still functioning as part of an overarching business process. And that's, I think, where I see some of often see some of the challenges when people are adopting event-driven systems, is some of the, like, I suppose like the day two stuff, like the how would you evolve it? How do you change it over time? How would you actually make a change to an event-driven system when you've just got producers producing events and subscribers subscribing to events, and these things are all happening independently? I think that's, at least with people I've worked with, that's some of the challenges that I've seen people encounter. It sounds easy at first. Yeah, we just publish events and everything's not talking to each other, and then it gets tricky as things get further and further down the line.
Yeah, it really is. It's an organizational challenge, like you mentioned before, right? It's a people process where folks have to agree on what the, not just the current state, but like you said, the future state, day two. I love that phrase. What are you going to do day two? A lot of, I guess, serverless communications and serverless articles and tutorials and stuff. It's a lot of how to get started, but it's not. There's not a lot of what happens on day two, because that's where the real work comes in. That's where you really got to put on your human brain and really think through the process. What you said about decoupling reminds me a lot of the, I guess, the fervor in conversation about functional programming, right? Like, functional programming doesn't have side effects. I was like, well, if it doesn't have side effects, isn't that literally just mean like writing some state after you do the work? Like, how are you going to fully perform the work if you don't have any kind of outside state to regulate, right? And so from that, we know that, companies are looking to scale their software by distributing, by going to the cloud, and by adopting these new architecture techniques. But in software, there's always trade-offs. You create a new level of abstraction. Yeah, you hide the servers, you hide the operating system, you even hide the HTTP mechanism for the most part, right? But then you have lovely little functions, our perfect Lambda functions that only do one thing and one thing well, and they're tiny. But I wanted to get your take on, how do we actually test these things now, because we've taken them out of the monolith. When they're in the monolith, they're quite easy to test, right? Because it's within the same process. Your dependencies are all aligned. You run your test, it spits up the application, does everything. It's great. But now that we're doing stuff in the cloud, especially doing things serverlessly, which rely on all these external APIs, what have you seen in your approach to how testing has changed? Both kind of like unit testing at first, and maybe we'll get into integration testing, and then really hot takes on how to mock the cloud.
Okay, we're going there. Okay, cool.
Like, I got you now, and we're gonna go there.
I'm here. We're recording. I can't leave. Oh no.
Our listeners are really gonna enjoy it, I think.
Yeah, I mean, I think like so. I would still apply a lot of the same principles you would use when testing any kind of distributed system, in a sense of, if you've got a distributed system, you're building with microservices, you've got 10 microservices. Under no circumstances do you want to be spinning up all 10 services to be able to test your system, because that's just unmaintainable. Then you kind of, all that coupling you've just worked so hard to reduce, you've just got rid of. And actually, if you do need to do that, that's probably a code smell or an architecture smell, in that if you need to spin everything up, then, well, you've built that distributed monolith that you so eloquently defined earlier, Paul. So I think, like, from a unit testing perspective, like mocking systems, running unit tests locally, mocking your business logic. But for that, I would focus very specifically on your business logic. Like, write tests that mock out databases, that mock out external calls, mock out everything external, the kind of traditional definition of a unit test, where you could be on flight mode on a plane and you can still run unit tests because there's no external dependencies. And that's all still really important. But where I think it's Shopify or Spotify, I always mix it up, but there's an article that they published on their engineering blog about the testing hexagon. So traditionally, people talk about the testing pyramid, where you've got this pyramid and you've got loads of unit tests at the bottom. For anyone listening on video, I'm making a triangle with my hands here if you're not watching the video. You've got a whole bunch of unit tests at the bottom. You've got a slightly smaller number of integration tests, and you've got an even smaller number of end-to-end tests. Whereas whichever one of Shopify or Spotify it is that defined this idea of a testing hexagon, where you've got a small number of unit tests that test your core business logic that would run locally. You've got more integration tests that are testing just your microservice, but with all of the integrations, the things it needs to communicate with. And then up at the top, you've got end-to-end tests. And I think when you're building serverless systems, typically you have a lot more integration points. Like you said, you've got individual Lambda functions. You might have tens, hundreds, thousands of them. They're communicating with SQS and SNS topics and event buses and databases and Kinesis streams. And there's all these things that are difficult to mock locally in a way that I would have confidence in. And we can come back around to that in a little bit if you want. So I think when it comes to integration testing, one of the things that I really like that has changed with serverless, that's really useful with serverless, is the idea of ephemeral environments, the ability just to spin up stuff and then spin it down again. And it only costs you when you need it. So to give you let's get this really practical for people for a second. Like imagine you've got a service that's hooked up to EventBridge. There's another service somewhere else in the system that's publishing an event onto EventBridge. You're consuming that event. Let's imagine it goes through an SQS queue first. So you've got an event hitting EventBridge, you've got an SQS queue, and then you've got a Lambda hooked up to your SQS queue, right? What you want to test is that when an event hits EventBridge, that your Lambda function gets invoked. Like that is the point of integration. What you can actually do as part of your tests is actually create your own event bus. Spin up your own event bus that's just for that test run. So you're spinning just an event, you're spinning up a new bus, hooking up your queue to that bus, not the actual main bus that everyone's publishing an event to. Then you've got a really well-defined, really controlled system under test. You're still testing the integration points. You're testing that your IAM roles are correct. You're testing that your Lambda is going to invoke. You're testing that your SQS queue policy is correct. But you're doing that in its own isolated way. In your test, you can then publish an event onto EventBridge in the format that you expect to receive. And we can talk about schema and contract testing as well if you want. And then you're testing all the integration points, and you can spin that up, publish an event, delete it all again afterwards, tear it all down. That is something that I just think is really, like when I've worked on systems that use things like Kafka, for example, like you can't just spin up an entire Kafka cluster for the purposes of running a test and then tear it all. Well, you kind of can with Docker Compose, I suppose. What I like about that approach with serverless though is that you're using the actual real thing. You're using the exact same thing that is going to use in production. So that idea of integration tests, and where you do have integrations with other services, just dynamically spinning up resources to be able to mock them other services, if you will.
Interesting. I hadn't really thought about leveraging temporary resources because they're serverless in the sort of like testing life cycle. That's really interesting. So would you say that is like EventBridge, you can create a brand new EventBridge just for your testing, and the operational costs is just an environment variable change, and the actual pricing of it isn't going to be that bad because you're just doing a few dozen tests, maybe like pumping events through it. That's a really good idea. I think that's a wonderful kind of takeaway for our audience to be able to lean into the distributed part of it, right? I think when I look at integration testing, I find like libraries that spend a lot of time and code on trying to mimic AWS perfectly, and you can't. And so that's the whole, argument, like you can't test, you gotta use the real live stuff, and you can't mock but so much. And it kind of even backspills into like, what does a local developer environment even look like these days with distributed systems and asynchronous events and working with the cloud and all of these serverless services. Once a solution is sort of put together and you're starting to implement it, how have you seen the developer experience change? A lot of people kind of complain about not being able to do things locally. What is your kind of answer and take on that?
It's I'm gonna preface my answer with the fact, like much like you, like I've been building with Lambda since Lambda was a thing. And I don't know if it's just that I've got used to myself the feedback cycle of I make a change, I run CDK deploy, it pushes the change, I run my tests against that pushed version of the code. And I don't know if I've just got so used to that life cycle that I can see as someone new who's maybe used to doing everything locally, where you've now got to actually push your code somewhere to then test it, I can see how that feedback loop would be frustrating. But then at the same time, I think there is an element of stuff you can do locally. So I am absolutely not a fan of trying to emulate the cloud locally. But things like DynamoDB local, as an example. This is an AWS official supported locally runnable version of DynamoDB. Perfect. Because then if I'm building some kind of API, I can spin it up, I can run tests against that, and it's AWS supported. It at least let me test my code locally. Becoming too reliant on that and not testing things against actual cloud resources and just relying on local testing misses a whole raft of issues. Things like IAM misconfigurations, IAM policy misconfigurations, misconfigured event bridge rules. Like there's a whole bunch of things that you just can't simulate locally, no matter how good your emulator is. So I think as far as like a local developer experience goes, like this is where unit tests are still really helpful. You can unit test your code. You can make sure your code does what it's supposed to do. You can make sure that, assuming this is the payload of the event that comes in, I'm going to run all this stuff. If you've got your code structured well, you could even invoke your Lambda handler locally in your unit tests, and you just pass in like a mock implementation of your SQS client or whatever it is. Prioritize unit tests locally to make sure functionally your thing does what it wants to do. You can iterate on that. You can iterate on that. You can iterate on that. I'm pretty confident that if I sub out a mock for an actual AWS SDK call, I'm pretty sure the AWS SDK call is going to work. I'm pretty sure. I'm pretty confident that's going to work because it's the AWS SDK and it works. So all you do when you're shipping that to the cloud is just literally just subbing out as little code as possible. You're pulling out that mock, you're subbing in the actual AWS SDK, the actual client. That's then going to make the call. But then you've got to be careful for things like IAM misconfigurations and things like that.
Yeah, I will say I don't do a ton in other clouds, but I do dabble, right? And the AWS SDK and the AWS like CLIs, they are as solid as you can get in terms of like software dependencies because there isn't a whole lot of churn. Only very recently have they started to like kind of pare back on certain APIs of things that are kind of less popular or haven't been doing as well. And so I really do believe in the AWS SDKs to be pretty solid so that when you are creating things, you can rely on the function calls, not really the function signatures not really changing that much.
Yeah, 100%. The other thing as well, which I didn't realize for a long time, but like most of the SDKs, if not all of them, like given what we're talking about before about like synchronous communication and the problems with that, like they all just have retries and timeouts and backoffs just built in. Like you get that for free. I only realized this relatively recently because I was doing some stuff. I was instrumenting something with Datadog. It's largely irrelevant that it is Datadog, but that's where I was visualizing it. And I was like, hey, this function got invoked and it was making a call to publish something. So I think it was SNS. And then there was a socket timeout. There was an error, and then it just happened again. And I was like, wait, why did it just happen again? It just made the call again. That was weird. And then I went and had a look, and yeah, they all just have like retries built in. So like, yeah, it's that's something I'd be confident just subbing out. I'd be interested to see what are your thoughts on the like local. What's your local developer experience look like in terms of serverless stuff?
Yeah. So for my favorite local developer experience uses this framework called Architect, arc.codes. It is a really like they do the DynamoDB local thing, but they don't use any like containers. It just purely mocks out API gateway and some core services, right? Not every service, just the main big ones. And that as a toolkit has been really great, and I love that. Without Architect, if I have to do stuff with other services that aren't within their kind of like happy code path, then I'll use something like SAM. And then sometimes you can do SAM invoke local, but most of the time I'm doing like what you're saying. You write some code, you push it, you deploy it, and then you test it against the live endpoints in the cloud. On your development environment or your staging environment, right? And because it's just a environment variable change away from prod to stage, they're very similar. Now, the thing I also wanted to ask you about is during local development, we kind of assume that the individual developer kind of has the ability to go and touch ephemeral states and go and touch these different branches and stages. However, in reality, with a lot of our clients, they have very limited number of accounts to work with. Right? I don't know. Do you see that a lot too?
Yeah,
And
yeah, 100%. Yeah, yeah, particularly in bigger organizations. Yeah,
it almost seems like an anti-pattern in serverless to like lock down your developers' access to ephemeral environments, right? Like if you're developing something and you need to be able to create a lambda to push stuff on and off a queue, you should be able to spin up a bunch of queues. But in reality, I see teams divided in like this is your account, this is the only account you get. You get one bus, you know. So how do you kind of see that, and what can we offer to the organizations, the people listening, to try to help not say like, yeah, your developers can do anything, but also we need more than one account.
yeah, yeah. I mean, I think there's absolutely ways to do it with a single account. I've seen it work with a single account, and it's just been slightly more creative with how you name your resources. So something I'm a really big fan of, and most of the times when I'm deploying anything is suffixing the name of the resource with the environment name. So you've got a environment variable that you set on your terminal, which might be env or environment. And obviously, when you ship that to dev, that gets set to dev. When you ship to prod, that gets set to prod. And then your resource, let's say it's a DynamoDB table, might be Paul's table dash dev, Paul's table dash prod. What that allows you to do is when you're on your local developer environment, you could set that env environment variable to James or Paul. So then when you ship that from your local machine to a single account, all of the resources that you create get postfixed with this environment. So there'd be Paul's table dash Paul and Paul's table dash James. And from in most resources that we're working with, at least in serverless, you've got a relatively high, you can create, I think it's infinite SQS You can create unlimited. I don't know what the limits are for other services. Now, the one that always gets people is EventBridge, because you can only have 5 buses per account, right? Which, if based on what I've just said earlier about just spinning up buses, deleting buses, you might be thinking, well, that's not going to work. That's silly. And where I've seen that work well is still maybe you do have one bus in this dev account, and you just get creative with how you define the rules. So maybe you include the environment in the source of the event that you publish to EventBus. So in prod, that might be dev.order. In dev, that might be dev.orders. In prod, that'll be prod.orders. When me and you deploy our own ephemeral environments, that rule that gets created is on JE-order.orders, PC.orders, which means if I want to then test my resources, I can still publish an event to this shared event bus that the other 10 developers on my team are all using. As long as I publish that event with JE.orders at the source, I know that that is then going to get routed into my own ephemeral environment, which I can then spin up and shut down. So I think it's just getting, like I do it almost entirely as in almost all cases now. Now I've heard a counter argument to that a lot of the IAC frameworks do like auto generated resource names, which are unique anyway, which is kind of useful. There's obviously the potential to end up with collisions if you're doing things like that, and some resources do, some resources don't. I prefer us to control it and just be like, hey, this is a dev table, this is Paul's table, this is James's table. And if it is resources that are constrained like EventBridge, then you can lock that down at a rule level. I'd be creative with how you do your rules. Which I would say if you're publishing things to EventBridge, you should always include the environment in the source anyway. It should always be like dev.orders, dev.products, I don't know, whatever, inventory, whatever the other mythical services that we're making up on the spot.
Yeah, that is a really good point, because we can use the namespace sort of as almost like a feature flag that it goes to the system, because it is distributed and does have these rules. We can leverage that fact, add your sort of unique namespace, and the event bus will just handle the rest. You don't necessarily have to create a brand new event bus because you're feature flagging that event through the pipeline on your own terms. Um, That's another really cool observation. I'm so glad we have you on.
No, I mean, so I've been there where, let's say I'm doing some local dev, and I set the env to -je because I'm doing my own stuff, and then maybe I set it to -dev because I'm doing something else on another system, and then I come back to mine and I deploy it, and then I end up accidentally deploying dev, and yeah, it can get a little bit confusing. But in most cases, at least from what I've seen, organizations of the size are the strictness that are going to be locking things down to a single account for everybody. They're also going to be locking down so that nobody can touch production, like nobody can manually deploy to production. So actually, yeah, if you manipulate the dev environment and you deploy some code to the dev environment that shouldn't be there, it might not be a problem. If you do that to prod, then that would be tricky. So yeah, it does require a little bit of care and attention, but it's a way of managing that single account problem.
Sure, yeah.
In an ideal world, give everyone their own account, though, people. If you're listening, if you're listening, like security teams, and just give people their own accounts and put the guardrails in place, people.
Oh man, my approach to security is just I assume everything I'm doing is wrong. So how can I put as little like information in as I can, right? Like just leave everything um out of like Git repos and out of source code, and let the higher level service, what do they call them? Service discovery systems that we end up coming up with, like how to deal with all those names, right? It's just like the internet and DNS. It's like, well, we have to route all this traffic. We still need a central place that has the global namespaces to be able to route stuff. So that will always be the place to look at and the place to really lock down, for security. And I think that actually takes us to the next part of our conversation, where I wanted to get your experience on, I guess, observability. Observability is a very large term for cloud, but as people move from monoliths to microservices to event driven to asynchronous to fully cloud native things, I think I see a lot of people missing, like, oh, I thought I had a resource here, but it's not there, or I thought I configured this thing, but it's not. I wrote everything in Terraform or in CloudFormation, but there's still missing parameters, and I have to go digging through the console and stuff like that.
Mm-hmm.
How has your experience been, sort of, as we adopt the cloud fully now? Is it just we just got to learn how to use the console better, or are there practices and things that we're missing out on?
Yeah, I think particularly when you're starting to build like distributed event-driven systems. So I mean, if we take a little bit of a further step back, like my good long portion of my career, and I'm assuming most people listening will relate to this, that debugging was as far as like console.log1, console.log2, console.log3. Okay, I got to 2 and I didn't get to 3. Okay, there's a problem somewhere between 2 and 3. Like, we're using logs, aren't we? We're using logs to debug things. Like, we're writing things in log messages and we're trying to work out what's going on. Like, but I think when you start building distributed systems, when you start building serverless systems, event-driven systems, I actually think logging is still useful, of course, but the ability to understand cause and effect, the ability to understand what is talking to what and why he's talking to what caused my system to run, what caused my system to do a thing, is much more important. Again, particularly when you're building event-driven systems where, hey, I publish an event and maybe there's 1 subscriber, maybe there's 100 subscribers. Who knows? Like, who knows? And equally, if I'm consuming an event, I want to know who published that event. So I think tracing, being able to do distributed tracing well, to be able to understand how the components of your system talk to each other, is absolutely fundamental to modern systems development, modern software development. To your point, what that would give you is, and this does require a little bit of embedded knowledge, I suppose, but imagine you're trying to test EventBridge to SQS to Lambda. Maybe then that Lambda goes off to EventBridge again. If you publish an event to EventBridge and your Lambda never runs, okay, you know then the issue is somewhere between Event Bridge and SNS. You know that the issue is there because your Lambda doesn't even trigger. If your Lambda does trigger, you start to see traces. You start to see that, okay, well, Event Bridge, a message hit Event Bridge, it then landed on a queue. My Lambda function was then invoked. You can see that in a nice, pretty graph if you really want to. You see that this thing happened, then it went through this channel, then it went to this service. But then there's no call out to Event Bridge. In your trace, you don't see the request of the message getting sent to Event Bridge. Okay, well, we can see there's a problem there. We can see that that request never happened. The request never went to Event Bridge. You can then visualize that. And then when you start propagating this trace information around, you start passing trace context, you start linking things together. It gives you that, I think, what is the necessary nuance to be able to really build an event-driven system and understand an event-driven system is to understand, okay, these things happened upstream of me and these things happened downstream of me. Now, to come back to your point about playing around in the console, like I think once you get to like CloudWatch is okay, like it's okay as a service. Like it's obviously not. Yeah, it's okay. I'm just gonna say it's okay. I can say that now. I don't work at AWS anymore. It's just okay. It's good for getting started. It's good for checking things out. I think once you get to a certain level, you're going to want to look at centralizing all of these things because if you're building microservices, you've got a well-architected AWS organization. Each of these different services are going to be in different AWS accounts. They're going to be dev, staging, prod accounts that are again all separate again, and you're going to want to be able to correlate that information together. So picking up some kind of third-party observability provider. Now, I know I work for Datadog. It doesn't have to be Datadog. Like generally, you're going to want to pick up something that allows you to see everything in one place, all of your trace information, all of your log information, all of your everything. Because once you've got that single pane of glass, air quotes, view, you can then really start to understand how these things link together. And even if you're only doing logging today, even if you're only still doing console.log1, console.log2, console.log3, in that console.log that you write, you could include a identifier, 1, 2, 3, 4. And then when you publish an event, you include 1, 2, 3, 4 in that event. And then when a service consumes that event, they can pull out that 1, 2, 3, 4, and then they do console.log 1, 2, 3, 4. And then you can go and search in your logs and say, hey, show me all the logs that have got 1, 2, 3, 4 in them. And hey, across all your systems, you can see this stream of logs across every single system that this has passed through. So I think centralizing things in one place is really valuable. And starting to think about cause and effect, starting to think about how the different components of your systems impact each other. Going back to what I was saying before about day two, like every software system everyone's ever built will break at some point. Do you have the required information to understand what your system is doing when it breaks? Is the question I would normally pose to people.
Yeah, for tracing, do you find that for tracing there's like a best practice for how to instrument your functions and how to instrument these services, right? If we're not just we're beyond just dumping info to CloudWatch, right? And we're trying to, like you said, consolidate it. And I love that executive word of single pane of glass. Executives love dashboards. It's like a universal thing. They just love dashboards. But how do you find that the community and your customers and users are finding that instrumentation process? Right? Because if I think about me writing my lambdas, I'm trying to write them as thin as I can so that they perform as well as they can. But I also need to be able to trace them and trace the stuff through it. So now I need to add, like, where am I adding my code, and like how am I supposed to handle this extra metadata flowing through for the observability?
Yeah, and there's multiple options in that area. So I guess if we start with the open source standards, there's open telemetry. Open telemetry, I'm sure most people have heard of at least. Open telemetry is a set of standards for how to do observability. It's a way of structuring telemetry data that is ubiquitous and understandable by everyone. Almost all modern programming languages have an SDK for open telemetry. You can use that to start a trace. You can add tags to your traces. You can annotate your traces. You can flush traces. Now, where that gets challenging with Lambda particularly is that most OpenTelemetry implementations flush traces to whatever your configured backend on a schedule. They do it on a batch. So they won't do it immediately. They'll do it every however many seconds or whatever. That gets challenging inside Lambda because Lambda obviously freezes execution environments when there's no code running. So when the code's not running, it freezes the environment, which means your traces don't get flushed. What that also means is that Lambda didn't run for n number of minutes and AWS took that environment back, then traces would never get flushed. And traces would never leave the Lambda execution environment. So you've normally got to do a lot of manual flushing after, the last thing you do before you return your Lambda function is flush the traces. That means you guarantee that you've got all your traces out of Lambda. Now, of course, that adds overhead to every single individual request because you've got to flush the traces somewhere. So what most observability providers do, and I think there's even an OpenTelemetry implementation of this, is they kind of run something as like a sidecar, what is called a Lambda extension. The easiest way to think about it is just a sidecar. There's another process running alongside your Lambda function. And that hooks into what's called the telemetry API, which is a new thing that Lambda added 2 years ago or something. It's like an internal API that you can call. You can register your extension with, you register your sidecar as an extension, which gives you an extra, I think it's 3 seconds. So after the function returns, the extension can keep running for up to 3 seconds before the environment gets frozen. So you can run this thing as a sidecar. You can hook into this telemetry API, which gives you the internal Lambda telemetry. And you can also ship your telemetry information to this thing that's running as a sidecar. Maybe you run a process on a port. You ship your things to that, and then you get that extra 3 seconds after so your Lambda function is returned. This is then going to flush the traces after your Lambda function is returned, which is then obviously saving you from a latency perspective. The trade-off that then gives you is that at cold start time is you've then got to start up this thing that runs as a sidecar. That's the trade-off. There's OpenTelemetry collectors you can run as sidecars. Datadog has its own agent, which can run as a sidecar. I think most of the observability providers who have Lambda-specific stuff do it in a very similar way, is they just run something alongside your code, and then you instrument your code either with the native libraries, the Datadog libraries, the New Relic libraries, whatever, or the OpenTelemetry SDKs, and then you're going to ship that to that thing that's running alongside your function, and then that is going to push it out to whatever observability backend that you're using.
How does tracing and observability work with the concurrency model of Lambdas? Do you have an answer for that? Because the Lambdas, they don't, as requests come in, more and more Lambdas spin up concurrently, and then each of those will have its own. Does each of those have its own like trace?
Yes. So a trace, by way of definition, a trace is a single request, the end-to-end flow of a single request by definition. So yes, that would be the same if you were running an application on a container. Each individual HTTP request that hit your API running on a container would get its own trace. So a trace is a end-to-end request flow. So as all these, even if you had one Lambda environment that received 3 requests, one after the other, each of them 3 requests would all get its own trace. That trace would then be flushed to the thing running as a sidecar. That would then be flushed to whatever observability backend that you're using.
Ah, I see. Okay. That's making more sense now. When I was first starting to look at the idea of observability in a serverless system, I was never sure exactly where to put the right, I guess, hooks in for instrumentation, right? Am I going to be putting it in my Lambda code, or am I going to try to grab stuff further down the line after, the work has been done? So all of those kind of questions still kind of come up, but I feel like they're more handled now. Serverless has really matured a lot in the last 3 years specifically. It's almost become more boring, right? To be like, oh, I need an API gateway with an S3 bucket and a Lambda function that spits to an SQ and then to a database or whatever.
And I mean, I think just if I could just talk into something you just said then, sorry, Paul, is so if I use Datadog as a very specific example, just because I know it well, when you add the Datadog extension to Lambda and when you add the Datadog SDKs, that has an element of automatic instrumentation. So you will automatically start to get information about your cold starts, what's happening in your cold start. You'll automatically get instrumented SDK calls, you'll automatically get instrumented HTTP calls, you'll automatically get propagation of your trace. If you send a message to SQS, it'll include trace information in it. And that's not unusual. OpenTelemetry does that as well. Like OpenTelemetry does that auto instrumentation as well. But where telemetry gets really valuable, and I bring this up because you were talking about where do you put things, observability gets really valuable when you can add specific business context to your telemetry. The way I like to put this is like asking questions of your system you didn't know you needed to ask. So imagine, Paul, you've built a serverless system. It's an e-commerce website. So the support team ring you up and say, hey, I've got customer James Eastham on the phone. Order 5678 has gone missing. We don't know where it is. Can you help us, Mr. Developer, Mrs. Developer? And if you had automatic instrumentation, you'll have all the telemetry, but how do you know which needle is the right needle in amongst all this big haystack of telemetry information? Once you start adding stuff in your code to actually add, maybe you annotate your traces with the customer ID and the order ID, which then allows you in your single pane of glass excited executives to be able to go into that observability backend and say, hey, show me all of the telemetry that relates to customer James Eastham. Show me all of the telemetry that relates to order 5678. Okay, so you run your trace query, you say, hey, show me all the telemetry related to order 5678, and then you see that, okay, I can see an API gateway request, I can see that it hit a Lambda function, there was an event published to EventBridge, and then, hey, nothing happened after that. Okay, so we know that message is lost somewhere in the ether of Amazon EventBridge because it got there and it never went anywhere else. So yes, there's ways you can automatically get trace information. Where it gets really valuable is when you start adding context. Yeah, start adding specific business context so that you can then question your system. And that does litter your code. That does mean you've got extra lines of code in your code base. Now, the counterpoint is you wish you had them when your system breaks and you've got no idea why.
Yeah, I tracing, I mean, even monoliths needed tracing, right? Everything kind of needs that ability. Once something is in production and is running and running and running, you almost, once it starts to run well, then you're expecting, all right, what's the one edge case that's going to break this? And then once it breaks, how will I find it, right?
Mm-hmm.
As we've been talking about the changes to modern software development and the kind of the cloud native environment that we find ourselves in now, do you have any, crystal magic ball look ahead about what the future of serverless might be like? Like, what are the emerging patterns or concepts that can really push these systems to the next level that you're seeing?
One thing I see changing, I think historically the word serverless, well, it's definitely been co-opted by marketing teams, cloud providers the world over to mean things that it isn't. And I think that has been to the detriment. And I actually think as we move forward, I think we'd be better placed as an industry to stop thinking about things as being serverless or not serverless. Like, are you using serverless? Are you using containers? Are you using Kubernetes? Are you using serverless? Like, I think that's almost the wrong way of looking at things. The way I've been trying to describe this, at least, and this isn't a new or novel idea. Like, I'm not made all this up myself. Is a kind of spectrum. Imagine a spectrum from right to left. At the far right, you've got like serverless first thinking. You've got Lambda. You've got things that scale up and they scale to zero, and they're magical and they're wonderful and they're all the things that we love. They don't suit all workloads. Like, I've seen so many people trying to massively optimize a Node.js Lambda function so it performs well enough to receive an API request. Maybe they've got like 200-300 millisecond latency requirements. Just run the damn thing in a container. Like just use something like ECS, use something like Fargate, take a step left on that spectrum. So you're using something like Fargate, something like Azure Container Apps, where you're still not worrying about managing servers. You're still not worrying about managing infrastructure. Yes, they might not scale to zero automatically. You're still not managing infrastructure. You're still not accidentally turning off Windows servers and when you remote desktops into them, right? Like there's still this whole category of things you don't have to worry about. And then maybe you've got another workload inside your organization that needs GPUs. It needs some hyper-specific infrastructure. Okay, that's fine. Step out, use Kubernetes. Like maybe don't use Kubernetes, people. Actually, don't do that. Don't do that. But you see my point. I think the tech industry seems to love like division and like, are you a Java developer? Are you a .NET developer? Are you a Rust developer? Are you a Go developer? Like, I think if we start thinking of things more as this spectrum of like, okay, I've got a workload that's asynchronous, it needs to process things off a queue, it needs to scale up, it needs to scale down, great, use Lambda. I've got a web API that my users want to be fast, my users want to be responsive, they want it to be online all the time. Whenever they hit it, it needs 300, 200, 300 millisecond response times. Run it in a container, or just write it in Rust. Like, that could be another option if you want to learn Rust. So that's like that's hopefully like what I see is we kind of lose some of these divisions between like, hey, are you serverless, are you not? It's like, just pick the right tool for the right job. Like, if you've got asynchronous, you're doing event-driven systems, you're receiving events off of event bus, use Lambda. If you're running a web API, maybe that's the right thing to use Fargate. Maybe it is, and that's fine. That's okay. It still means you don't have to manage infrastructure.
Definitely. I'm always last year really, I was like seeing the shift to just say we're cloud engineers, not really serverless, not really Kubernetes. We're just cloud engineers because we are dealing with the deployment model. We're dealing with the operation programming model. Um, and the future of serverless will continue to be more magic layers created by other vendors. The inclusion of the extra vendors like Vercel and Netlify to bring front end folks to the back end with magic serverless functions.
Yeah, Cloudflare are doing some really wild stuff. Like, Cloudflare is so good, so good.
Yep. Or even like, I'm a big JavaScript person, right? And I keep up with all of that ecosystem as well as the cloud stuff. And I'm definitely seeing front end developers starting to understand like the power of leveraging server side stuff and not having to deploy everything in a giant Node.js container.
Yeah.
And so I think the future is still good for cloud native services and making things simpler. One day, I don't know how it'll happen, but hopefully, I don't ever have to worry about regions anymore. That's my dream.
Yeah, so that's one of there's a really good podcast that I can share if you want to put it in the show notes, with the VP. I think it's the VP of engineering at Cloudflare. And she says exactly that. Like, developers shouldn't have to care about regions. And that's one of the things that Cloudflare does, is they will look at where your users are, where your users are accessing your system, and they'll dynamically shift your workload around the world to put it where is the most sensible place. And they'll even do really smart things. Like, imagine you've got a Cloudflare worker, which is a function that's connecting to, I don't know, a database that's running in AWS, for argument's sake. They'll run the analysis to say, are we better putting your application code close to the users and letting the database query traverse the internet? Or are we better putting your workload closer to the database and letting the users traverse the internet? And they'll do that without you doing anything. They will just run your workload in places. Now, this gets a bit tricky when it comes to like GDPR and like data residency requirements, but as like a idea, I'm completely with you on that. Like, I love it. Like, yeah, why do I need to care about where my system runs? I just want it to run. I just want it to go.
The amount of times I'm trying to find something in the console. Again, maybe I'm just really bad at the console, but like, I will always like be like, am I in the right region? Like, where is this stuff? Oh, it's the other region, and stuff like that. Okay, well, we're coming up on the hour, and man, this has just been a blast talking with you, James. I've learned a lot of very specific things that I think I can write some blog posts about, and then totally credit you, of
Oh, I'd
course.
love to see that.
But I leave the hard hitting, super serious questions for the end. And I took a look at your LinkedIn page. I stalked you a bit and realized that you are a traveled person. Like, you have seen and done things all around the world. And that's really cool. And I wanted to ask you, you know, what's one adventure or trip or experience that you've had that you recommend that everyone try? Like, something that really impacted your life and is actually kind of doable for folks. I'm not saying like you have to go on an all expenses cruise to Alaska or whatever to see the aurora borealis, but what are some of the things? What's one thing that you've seen that you really recommend for folks to experience as well?
I can give you one thing I've seen and one thing to do. No, let's just do the do. Let's just do the do. So when I finished college, which I don't know what that is in the US, when I was 18, basically before I went to university, I don't know. I don't think college quite
Yeah,
translates.
college is university. So when you finish high school, what we call high school.
yeah. I didn't know what I wanted to do, so I didn't want to go to university, but I didn't know what I wanted to do, so I went backpacking. Now, so I spent 12 months backpacking. Now I realised that isn't in everyone's budget because 12 months just jetting off around the world. But one part of that I reflect on sometimes is staying in hostels, like shared dormitory hostels. So like, you might be in a room with four bunk beds or six bunk beds. There's 12 people in a room. And hostels are obviously incredibly cheap. That's why backpackers use them, because they save you money. But actually the people you meet, you get a massive eclectic group of people staying in hostels. You might have, a 65-year-old guy who's just traveling on his own because he's retired. And then you might get, I don't know, 3 Spanish people and an Italian, me, the Brit. And you just get this collection of people who are all then in this shared living space. And I think it's a really, both an incredibly cheap way to travel, but also an incredibly good way of meeting people and meeting different communities, different cultures. Like, I think we could maybe all do with a little bit of that at the minute. It's like a bit of cross-cultural and meeting other people and appreciating other people's views on things. So yeah, that and obviously you can do that anywhere. Like, hostels exist anywhere. Like, you just staying thinking and experiencing other people and other cultures and different people and kind of getting outside of our own little bubbles that we all live in, and kind of seeing other things like that. When I reflect, when I think about it, that's been the
That's beautiful.
thing. That's, yeah. The slightly more flippant answer is run an ultra marathon, but I realize again that isn't in everyone's.
Oh, ultra marathon. Is that like more than a marathon? I don't even know.
Yeah, anything over a marathon is counted as an ultra marathon,
Oh my God.
and that's
I don't move much, admittedly. I'm not one of, I do not take to physical movement quite so well. I play DDR, and that's about it. The Dance Dance Revolution game. I love that. But it's so beautiful that, your experiences around the world is really just people, and, getting into a position or an opportunity where you can really get outside of your own bubble, really get outside of your own headspace, and experience humanity for its entire spectrum. That's very beautiful too. Just like,
yeah. And when you think about the kind of work that you and me do, and you're in a community, and you're, I think, and I've not really thought about this until like right this second, actually. But the kind of work I'm doing now, like DevRel, communities, meeting different groups of people with different experiences, like I can actually see a direct impact from like a career perspective on having spent so much time when I was younger, like dealing with different classes, different nationalities, different races, like everything I can actually see. And again, I'm kind of, this is coming to mind. This has been a useful podcast for me to kind of self-reflect a little bit and think about some of these questions. But yeah, I can actually see a direct correlate, not correlation, that's the wrong word, like a direct impact there on my career.
yeah, heavy influence, being able to bring people together. It's important. Again, serverless is a spectrum, humanity is a spectrum. We all need to exist together in this distributed world of ours.
Yeah, there's a lot of parallels. Yeah.
Well, with that, everybody, we're going to go ahead and say this has been a wonderful conversation with James Eastham, DevRel Serverless Advocate at Datadog. We talked about testing and distributed systems and world peace, all of these wonderful things. And this has been Talking Serverless, sponsored by Serverless Guru. Serverless Guru is your place to figure out how to do better in the cloud. Feel free to drop a comment. If you like this podcast, give it a thumbs up. If you didn't like the podcast, give it a thumbs down. All the engagement helps. So, and with that, thanks so much, and I'll see you on the next one.